In this video, we are going to look at how to convert into trig notation using multiplication or division, but then convert your answers back to standard notation in the very end. Okay, so this is going to be a multi-step process. So the first thing that we have to do is we have to be able to take the information we have and convert it over to trig notation. Then we can multiply or divide depending on what the trig notation is looking like, and then take the overall answer we get and convert it back over to standard notation. Okay, so let's go ahead and take a look at this first example. So you can see I have two forms, or two different standard form equations, and they are being multiplied. Okay, so we have to look at them first as individual pieces. So you can see here I have two coordinate planes. So what we're going to do with each of these coordinate planes is we are going to put in the appropriate triangle. So for this first one, let's go ahead and look at negative square root of 3 plus I. So in this case, we have the negative square root of 3 plus I. So we have to be able to translate that into our triangle here. So this is actually going to end up being here in this second quadrant. Now you can see that because my A is going to be negative square root of 3, and my B is going to be 1. So we're going to go ahead and we're going to draw our little triangle here. So we've got our angle here. So this is the negative square root of 3. My y is 1. And so if you look, I have 1 square root of 3. This is considered to be a form of our special triangle. It's going to make this 2. However, do make sure, and you always check your work, you do that by remembering that z is equal to the square root of a squared plus b squared. So let's just really quickly double check and make sure we were right here, that my radius for this z line is going to be 2. So again, this is going to be the square root of negative square root of 3 squared plus 1 squared. So negative square root of 3 is going to leave us with 3 plus 1. So this is going to leave us with the square root of 4, which gives us 2 as a result. Okay. So now that we know that, we know a little bit about this triangle in itself. Okay, so first and foremost, if we look at this, we can determine what this reference angle is. So this is going to give us that the cosine of my reference has to equal negative square root of 3 over 2. So if we take a look at that, negative square root of 3 over 2 means that my reference angle is going to be 30 degrees. Okay. So if the reference is 30 degrees, then in order to actually find this angle here, let's go ahead and call this alpha. So to find our alpha says that I have to do 180 minus my reference. And so in this case, this would be 180 minus my 30 degree reference gives me 150 degrees. Okay. So we need to set that information aside for just a minute, because this is the actual angle that we were working with, and we will come back to use that later. We have to do our second triangle. And so you can see here my second triangle is going to be 1 plus I square root of 3. So we have to go ahead and fill out that second. So this triangle here, notice A and B are both positive, so that puts it here in our first quadrant. So we're going to go ahead, draw that triangle here. So this again is going to be our reference, and here we're going to end up with 1 square root of 3. If you notice, this is very similar to the triangle we just had here, and so my radius again ends up being 2, or the z value here ends up being 2. So we have to be able to, just like before, find that reference angle. So we have, say, the cosine of my reference is going to be, and cosine is going to be adjacent over, so this is going to be 1/2. So if we look at that, that tells us that my reference angle is actually going to be 60 degrees. Now the rule that we use, so again, this is the angle that we are also looking for, so we can call that beta. And so here, if you remember, the rule says that in the first quadrant, this is going to equal your reference angle. So this means that my angle is 60 degrees. Okay, so we've got our two triangles. We've got our angles from them. We also know our z term. It's the same in both, which it hopefully should be. And so therefore, we know that it's going to be 2. So I have to create my trig notation for my first triangle and the trig notation for the second triangle so that I can multiply them together. So let's look at the first. My trig notation for the first one here is going to be, again, trig notation is z times the cosine of the angle plus I sine of the angle. So my first triangle here is going to be 2 times the cosine of 150 plus I sine of 150. My z for the second is going to be 2 times cosine of 60 plus I sine of 60. Now these two terms here are being multiplied, so we have to actually multiply that together. So we are going to do 2 times the cosine of 150 plus I sine of 150. We're going to multiply that by 2 times the cosine of 60 plus I sine of 60. Again, multiplication says multiply the two z terms, so this is going to be 2 times 2, and then this is going to be the cosine, and we're going to add the angles. So 150 plus 60 plus I sine of 150 plus 60. Simplify everything and we get 4 times the cosine of 210 plus I sine of 210. Now that's just the beginning. This was just simply combining it together. Once we get to this, we have to finish the problem, and the problem says that you need to convert back to standard notation. So we have to take what we just found and now we need to go backwards. Okay? So first we need the cosine of 210 degrees. So one thing that you can pull out again is your handy dandy trusty unit circle. And the first thing you would want to look for is to see if your degree measure shows up. And here it does. Here's my 210. And so this is the coordinate points that I care about. And so we have the x and the y. Okay? And so this tells us sine and cosine. So again, here's going to be my triangle of the 210. And so with that, I can pull my terms here. So we are going to end up with 4 times negative square root 3 over 2 minus 1/2 I. And then just like before, you need to factor this in. So this is going to give us negative 4 square roots of 3 over 2 minus 4 over 2I, and then you need to reduce. And so in this here would come down to being negative 2 square roots of 3 minus 2I. And this is the overall result that we are looking for to combine those two terms together. So I did an example multiplying. Let's go ahead and look at one where we divide. Okay. And so first and foremost, again, we've got my two coordinate planes here, one for each triangle to make it easy to see, which means we got to look at the numerator individually and then the denominator individually. So let's go ahead and start with the numerator. And so here we have 3 minus 3 square roots of 3I. So my x term, or my x-axis is positive, my y is negative, so we're going to be down here in quadrant 4. So let's go ahead and just simply drop in our triangle here. So this is going to be our reference angle. Again, we're going to have my x, which is 3. We're going to have the y, which is negative 3 square roots of 3. We need to find the length of our radius here, and so again, remember, z is equal to the square root of a squared plus b squared. So in this case, it's going to be the square root of 3 squared plus negative 3 square roots of 3 squared. So this is going to end up being 9 plus negative 3 squared is 9 times 3 is 27. So this here is going to end up being the square root 36, which equals 6. So I have my triangle all filled in. And so with this, I need to kind of pick out or do my, say, important information, which one of that has to do with, I need to actually know what my angle is here. So the angle that I'm looking for is going to start at 0. We're going to wrap all the way around to get to here. So let's go ahead and call that alpha. So because we're here in the 4th quadrant, okay, in order to find it, says that my alpha would be equal to 360 minus my reference. Well, I have to find my reference in order to find my actual angle. So to find my reference says I need to utilize my triangle here. So there's a couple ways that I can find the reference. One, I could use cosine or I could use sine. To use sine says I'm using the opposite. I really don't much want to use the radical, so I'd go ahead and use cosine. So here, let me switch up colors here. I would have that my reference, or the cosine of my reference, is equal to adjacent 3 over 6. However, I can reduce this, so this is going to equal 1/2. So in doing so, that makes my reference equal to 60 degrees. Therefore, to find my alpha angle, that says I do 360 minus my 60 gives me 300 degrees for my angle. Putting that all together, that tells me that I have z, which is 6. So this is going to be 6 times the cosine of 300 degrees plus I sine of 300 degrees. Alright, now let's do the other one. So my other one down here is going to be the square root of 3 minus I. Again, my x is positive, my y is negative, and so that in itself means I'm down once again in this fourth quadrant. So I'm going to go ahead and draw that triangle in. This is going to be my angle of reference. So we're told that my x is going to be the square root of 3, my y is negative 1. That's going to make this my special triangle 2. Again, like before, if I look at the cosine of my reference, that's going to be the square root of 3 over 2, which in this case makes my reference angle 30 degrees. Since I'm here in this fourth quadrant, I'm looking for this angle here. So this says, if I call this beta, that my angle beta is equal to 360 minus my reference. So this is 360 minus that 30 degrees, gives you 330 degrees. And so just like before, I can write this out. So I'm going to have 2 times the cosine of 330 plus I sine of 330. Now, if we go back to the beginning, this is division. Okay, so I've got my top divided by the bottom, and so I need to go ahead and write that out here. So we are going to start with 6 times the cosine of 300 plus I sine of 300 divided by 2 times the cosine of 330 plus I sine of 330. So in doing that, you're going to divide your z's, so this is going to be 6 over 2, and you're going to subtract your angles. So this is going to be the cosine of 300 minus 330 plus I sine of 300 minus 330. And now we need to reduce. So 6 over 2 is going to reduce down to 3. And this is going to be the cosine of negative 30 plus I sine of negative 30. Now, there's a few things here that we need to pay attention to because we're dealing with this negative value. So here, with this being a negative value, one of the things that we need to recall is that the cosine of a negative value is the same as the cosine of the positive, and the sine of a negative is equal to negative sine of the positive. So we can rewrite this removing those negatives. And so here this is then going to be 3 times the cosine of 30 minus I sine of 30. So here we now have the cosine of 30 and the sine of 30. And so again, we would have to identify what those are. So we know the cosine of 30 degrees is going to be the square root of 3 over 2. And we know the sine of 30 degrees is going to be 1/2. So we need to plug those in. So this is going to give us 3 times the square root of 3 over 2 minus 1/2 I, which is going to become 3 square roots of 3 over 2 minus 3 over 2 I. And here would be the end result. So there's one example using multiplication, one example using division. Remember, you are starting with standard form, you are converting over to trig notation, using your triangles in order to multiply or divide through trig notation, and then converting back to standard form in the very end. So if you have any questions, please let me know. If you find extra or other examples that you would like to see, let me know those as well. I would be happy to work them out for you. Otherwise, I hope you enjoyed, and I will see you next time.